Okay, so let's get started. We're going to be taking a look at how to dial in our spark timing within this training module, utilizing our knock control as a guide to how far we can actually push our spark timing before it's unsafe. In the last training module, we explored setting up our knock control and doing a quick demonstration of how it's actually going to work. Now we've figured out what the optimal frequency was going to be for this particular engine running a factory knock sensor. So I'm dealing with a Honda K24 engine swapped into my Honda EP3 chassis, and I'm using the OEM Honda knock sensor. We found, based on doing some testing, that the frequency that was optimized was 14,000 hertz. That gave us the best signal to noise ratio from the knock sensor, meaning we have the most pronounced output from the knock sensor while going in and filtering out noise that the engine is producing. Now this training module, we're going to actually optimize the knock control, figuring out what the knock threshold values should be for our engine, and then we're going to go through and actually dial in our spark timing, seeing how far we can push things before we see knock, and also looking on our mainline chassis dyno to see, as we're bumping our spark timing in, what the results are going to be. Now you can do this process without a chassis dyno, but it is much easier to dial in and tune your spark timing with a chassis dyno rather than doing road tuning, but you can get fairly close. Again, watching what your knock sensor is showing you is really key. As long as we've calibrated it properly, as I demonstrated in that last training module, we can rely on it for accurate knock detection. So let's jump in here and take a look at a few things that we need to get in line before we actually do any spark timing tuning. First thing, under our knock tuning page here, I'm going to jump into the threshold table and grab the entire table values and put them at a value of 100. 100 is going to be the highest value we can place in here. We can see right here is going to be the upper limit. 100 is going to be the highest we can place into the table. Now we're raising the knock threshold up, so we don't have to worry about the knock control kicking in as we're trying to figure out what the threshold value should be at. We're also going to go in here to our knock trim limit. This is going to be how much ignition timing we can reduce. I'm going to change the entire table here to something like 0.1. 0.1 is the lowest amount of spark retard we can place into this table. So now we've effectively bypassed the knock control. Now the next thing we need to do here is jump into our spark timing table and start to reduce the values way down. We want to be able to do a baseline pull to figure out when the engine isn't knocking or pre-igniting, and we want to find what the knock threshold is going to be in a no knock situation. So this is going to be the next step of moving from our knock tuning page into our ignition tuning page here. Now taking a look, we're going to find this block or area here at 25 to 3000. That's what we were using to test the knock frequency in that last training module and essentially put the engine into knock conditions. Now this engine is going to be about a 12.5 13:1 compression engine, and I am on pump gas, so it is going to be very knock sensitive. We're likely to find we reach knock before maximum brake torque, and that's the case with a lot of high compression engines when you're running them on a lower octane type of fuel. What we're going to find here is that above essentially 80 and the engine load normalized, which engine load normalized is set up for the MAP sensor, so it's going to be the inlet manifold pressure sensor. So 80 would be 80 kPa. 80 kPa and above, we're going to find that we have values here in the table of something like 20 degrees. Now this might be more optimized for making power, but in order to figure out our knock sensor, the knock sensor threshold table values, we need to go and lower this down to about half of what we expect the spark timing is going to be within the main spark timing table at wide open throttle conditions. Now, I would expect most 4-cylinder, 6-cylinder, 8-cylinder engines to be able to run at least 20 to 24 degrees of spark timing advance on something like pump gas. So what I'm going to do here is put my values about half of that. We can go about 10 or 12 degrees will be a really solid starting point that'll allow us to feel out the engine, figuring out what it's going to do with a no knock situation, to figure out the knock threshold table, populate those values, being able to then turn on and arm the knock control, and then bumping our timing values up here in slow increments, 3-4 degree increments, and watching what the knock sensor output's going to do. If we're finding that as we're bumping the timing in a certain RPM range that we're getting knock, we need to back the timing away. It's just not going to be something we can run. Again, we can rely on this entire system because we've went through and done the work calibrating the knock sensor in the last training module. If you skipped over that last training module, definitely jump back in and watch it from start to finish. A lot of good information in there to get everything dialed in and set up for your engine. What I'm going to do here is go from 2500 and higher And I'm going to go even here from 80 kPa and higher in the engine load normalized axes. I'm going to set this to 10 degrees. Now again, 10 degrees is extremely conservative, and the power output out of our engine is likely to be pretty low, but I don't really care about the power output right now. Again, I want to put the engine into a no knock condition. Now, some other things I want to talk about here. I have went in and set up and got my volumetric efficiency table fairly close. When we're dealing with our VE and airflow model tuning, so whether it's variable valve timing tuning or whether it's our VE airflow based tuning, injection timing tuning, whatever we're doing within the air and fuel modeling, we want to make sure that we have low spark timing before we head into even dialing in our airflow model. So before we even touch our volumetric efficiency table, we want to have a little bit lower spark timing so that we don't have to worry about knock or pre-ignition. So the values I'm placing in the table here will set me up for that particular condition. Let me go ahead and just raise the values here at about 12 degrees. That's going to be about half of what I expect the spark timing to be at here on the engine. Just taking a guess, but that's again about what I'm going to expect here. So let's go ahead and store that change to the Motec. So, volumetric.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.